Okay, we're going to do question 1E, part 2 of the exam paper. This is an excellence questions, obviously, and it's about finding either, you can do either, find a mean or standard deviation. And we'll work through both, okay? In order to do this, I think that we need to go back to maybe a bit of a simpler example. We've done this example before. I'm just going to go through it and then you can check it. So let's just look at calculating a mean from a given bit of information. So we've got, we've been given the probability of 0.657. So we're looking at the probability that x is less than 903 is 0.657. And the standard deviation is given as 17.3. Calculate what the mean would need to be in this situation. So what we're saying is, if we look at a graph, this is our 903, and I draw this over here because we're looking at an area that is 0.657. So that's, and we're looking at x being less than this. So if 903 is our boundary, what's the probability that a value will be less than 903 and it's 0.657? That's the probability of it, that's given. And we want to find out what the mean would be in that situation. That we have 903, we have 0.657, a probability that a value is going to be less than that. What would the mean have to be? In order to do that situation, we have to come over here and do standard normal. We have to standardize the situation. Because what we have to do is figure out how many standard deviations away we're talking about. How many basically standard deviations, for example, away is 903, above the mean basically. And in order to do that, we have to standard normal things. So we're basically going to have a mean that is at 0 and a standard deviation that is 1. And that's how we do these types of problems. And so in order to do that, we're going to have to put into our calculator the 0 and the 1, and the area basically, and if it's a TI, it has to always be the area to the left. That's the convention that you must use, right? So we're going to put into the calculator 0.657, and then again, if it's a TI or a Casio, it's a little different. But in a TI, you would go 0 and then 1. In a Casio, it actually tells you, and I think the order is actually different. But we'll put that in. And what we end up getting, when we execute that, you can put that into your calculator and see, but you get an answer of 0.40, stop it, 0.40420 or something like that. Now that is 0.404 is how many standard deviations above 0.4 above the mean the 903 actually is. So that's our Z score. So now we found that Z is 0.404, okay? So that means, again, that if we go back to our drawing, that value is approximately 0.404 units above the mean, above the average. And so now we can use our formula. Our Z is equal to standard deviation all over that. We can use that to rearrange and find the mean. So all we do is we plug those values in. X is 903 minus, we know what Z is now, it's 0.404 times the standard deviation of 17.3. So this is what we have. We have 903 minus 0.404 times 17.3. It's a little hard to see, but anyway, you get the idea. And you work that out. So when we do the calculation, we've got 903 minus 17.3 times the 0.404, and you can round it off to how many decimal places you want, and round it off. So now we know that a mean of 896 approximately is what's got to be in there for the 903 to be the value of which 0.657 or 65.7% of the values must be less than. That's what we're talking about, and that's how that's interpreted.